Alright guys, so we are on to astronomy review. This was back to our first unit, so this might be some stuff that you have to think about. Okay. Remember, inner planets are called terrestrial. Outer planets are gaseous. And in here, this would be the asteroid belt. Our solar system consists of the sun, planets, moons, asteroids, comets, meteors, dust, and gas. Our sun is our major source of heat and light. The light travels in the waves to the Earth. Planets are the largest objects other than the sun. They revolve around the sun due to its gravitational pull or rate. Gravitational. Revolve means to go around. Moons are called natural satellites. I mean, they're automatically there. They're not something we have put there like the International Space Station. Gravitational pull of the planets are what keeps moons in orbit. We have one moon, Mars has 2, Jupiter has like 55. Okay, different moons, bigger planets. Asteroids are rocky masses in orbit. Let me move this so y'all can see. Comets are frozen masses in space. Meteors are burning masses in the Earth's atmosphere. Remember, meteors, they come through the atmosphere, they burn up as they're going. Meteorite is what hits us because it didn't burn up. Dust and gas is just various particles. And then there's mostly hydrogen gas, if there's gas. Rotation and revolution of each planet. All planets usually go clockwise. Okay, clock goes like this, except for Venus. Venus does go the other way. I think I said that backwards, y'all. Counterclockwise is how we go. For us, we revolve 365 days. We rotate every 24 hours. That's why we get day and night. Different planets like Jupiter spins faster. It would get day night every 10 hours. I think Mercury is about the same for rotation and a revolution. It's like 200 and some days. The movement of all celestial bodies in a solar system can have an impact on one another if they are in close enough proximity. If they're close to each other, they can have a pull on each other. Kind of like if you can't help someone up from across the room, but if you're right by them, you can reach your hand out and help them up. All objects with a significant mass have a significant amount of gravitational pull, meaning bigger they are, the more matter that's in them, the more pull they have. The sun is the biggest thing, has the most mass. It keeps all the planets in orbit. Here's the sun. You can see there's the photosphere, the cornea. Oops, sorry, y'all. The solar flare, sunspots, the darker spots, prominence where it flies off, flare where it comes back, or prominence where it comes back, flare comes off. Phases of the Earth's moon. Remember, it is a new moon when the sun is shining behind it, and all you see. So if the sun is coming this way, you see blackness. So what's what we call a new moon because we don't see the moon. When the sun, it's a full moon when the sun is shining at it, and it's what we see. That's why this is it over here on the opposite side. As it goes around, you see bits more of light until it goes back to a new moon. This happens about every 28 days or one every month. That's why you have at least 12 full moons a year, 12 new moons, etc. The moon stays in orbit around Earth due to Earth's gravitational pull. In return, the moon affects many aspects on Earth, including tides, eclipses, and orbits. High tide, low tide, if we can have solar eclipse, lunar eclipse, how it's moving around. So a solar eclipse, you have the sun. The sun is shining on the moon. Okay, this would be a new moon. And because it's shining on there, if it lines up just perfectly, it creates where we can't see the sun because the moon goes in front of it and gives a shadow on Earth. You have the total eclipse in the dark area, a partial eclipse in the outside area. Fancy names is umbra and penumbra. I don't really cover that here in 6th grade, but you know. When we had the eclipse back in 2 years ago now, 3 years ago now, I don't know. We were in a partial eclipse. We weren't right in the eye of totality. Lunar eclipse. So again, this is where it should be a full moon. The moon should be shining bright. We should be able to see the whole moon because the sun is shining on it. But then Earth comes and goes, ha ha, you can't see the moon, and blocks it out. So when it should be a full moon, and then it's covered. Again, you have the umber where it's completely dark, the prenumber where it's a little bit dark, and you can see the moon orbiting around. Tide types on Earth. So remember, the sun also affects tides, not just the moon. The moon is the direct effect because the moon is closer to us than the sun. So if the sun and the moon, where'd my cursor go? The sun and the moon line up, you get an extreme high tide. We call this a spring tide. And it's where you can see the high tide is like double because the moon and the sun are both pulling on that water, and you have an extreme low tide over here on the other sides. If the sun and the moon are opposites or 90 degrees, you notice that the moon has a higher tide, moon tide, sun tide. So that, it's still a high tide more towards the moon, but the sun is also having some pull on it. We call this a neap tide. All right, page 13. It wants you to describe space exploration technology types listed in the chart. I didn't like that chart. So I went and made my own thing. Ta-da! All right. So I will try to post this too. We're going to talk about what is manned versus unmanned. What is a space shuttle versus a space probe? What is the ISS versus a satellite? Those are the things that I think that you needed to really know in sixth grade science. So manned versus unmanned. Manned is astronauts go to space to observe. A benefit of having a manned spacecraft, it is more accurate, more hands-on. Unmanned technology such as satellites, orbiters, and probes are going to space. Good thing is it costs less. It's only $420 million. There's a less chance for accidental death. I come down here, boys and girls, I have what are some of these things. So like an orbiter is robotic spacecraft designed to orbit planets for a long duration space missions. They go around. A probe is a small device usually attached to an orbiter or a satellite. It is detached during a flyby and launched towards the celestial body, planet, moon, etc., to obtain information. A flyby is when the spacecraft orbits a planet or a celestial body and drops an interplanetary probe to obtain information. Unmanned is a spacecraft that does not have a human crew. Example would be Sputnik. And a manned spacecraft, it is controlled by a human crew of astronauts. Example, Apollo's 13. So back to where we were, we have a space shuttle versus a space probe. So a space shuttle is a large, complex, manned spacecraft that is designed to carry people, satellites, probes, and parts of space stations or experiments into low Earth orbit. Good thing is it is reusable and it can be flown many times. A space probe is small, unmanned robotic spacecraft that are sent to explore other moons, planets, asteroids. It is then destroyed or abandoned after their mission. Good thing is they can go places we can't go. Bad thing is it's not reusable. We made it to Pluto back in 2014. It took 10 years to get there, and it's kept going. New Horizons has kept going. The one they just launched into Saturn a couple years ago, to get more information. It had been circling for 20 some years and it was running out of gas, so they launched it in so they could get a look at the rings. ISS. No, not you're in trouble at school. International Space Station versus just a satellite. The International Space Station is a habitable, human-made satellite that orbits Earth at an altitude between 205 to 270 miles. It is as large as a football field and weighs 925,000 pounds. We didn't just launch it all up together. We launched it in different pieces, and then they put it together in outer space. Okay. There is sometimes that you can see it flying by. It is a research laboratory and observatory. You can go there and conduct experiments and can test other spacecrafts. It acts as a storage. a staging base for other missions. So people will fly there and then launch if they're going somewhere else. People go there to have, like, if they have to do an experiment in zero gravity, they'll go there. People have lived up there. I think the longest is just over a year now. And so it's a good place to do experiments. It's a good place to get more information about outer space. A satellite is an artificial object that is deliberately sent into orbit in space, usually in order to send, receive, or bounce back information. Usually launched on rockets to get to their orbit. They must keep traveling and staying in orbit. There are three types, okay? The benefits. There are three types. There's a fixed, which is billions of voice, data, video transmissions, etc. There's mobile. This is how we have GPS. And then there's science research. This is meteorological data and land survey. You know, when you go to Google Earth and you can find your house, this is coming from scientific research satellites. Okay, remember I said there's natural satellites, the moon, because we didn't put the moon there, but the moon circles us. Satellites also just circle us and give us those three types of information. As I said, you can either pause the video or you can come back to look at this information, but these are the things you need to be able to know the difference. Manned versus unmanned. What's this, just a space shuttle versus a space probe? What is ISS versus just a regular satellite? If you have any questions, let me know, and we'll talk about this in class.